So when we are planning that, we have understood the variables used here, the tokens used in the source languages, and the way they are being written. Is it according to the set of grammar rules of that programming language or not? So we all have resolved these things in our front end phases. Then we will plan to convert that to target language or to either machine level code or assembly level code. That means we are planning to translate it. So there comes your backend phases. So there, how do you translate? How do you convert from your source language to the target language? Those phases will fall under your backend phases. So we will discuss from there. Okay. Now let me share my screen first. Is my screen visible?
No. It's till now it's not visible. It's no, madam,
Not visible.
not visible. Yes, ma'am. Now
Yes,
it's
ma'am. Difficult.
now it's visible.
Okay. Okay. So what I was discussing is the number of phases. So let me first open my number of phases, my PPT. So these seven phases, in among the seven, some of them belongs to front end and some of them belongs to back end. Okay. So that is what in my PDF you can see that the whole compilation part is being divided into two different parts, the front end and back end, which you have already seen in the green blocks in my PPT. In my green blocks, you can see the front end and back end. So this front end part is treated as a analysis phase. Remember, the front end part, we treat it as an analysis phase because here we are doing some kind of analysis job. That means we are, just wait for a second. Yeah. So, so the front end part, the green first block which you have seen, that part we treat as a analysis part. Why? Because we are mostly busy with understanding of our source language. That means in the language in which our code is written. So we have to first process that source language. So maybe we have to first understand whatever tokens user have used in those tokens. What are the categories of tokens a user have used? Now, what is token? What is a lexeme? I will discuss it later on. But just to give you a glimpse, that token means the smallest unit. Okay, which is separable from other unit. Okay, the smallest unit by which your code is written. Okay, so basically we are trying to find out these pieces, these constituent pieces which is present in your source program. Then only if we can categorize and if we can understand the relationship between those tokens, then we can easily find out that whether those are written according to the syntax or semantics of the source language or not. If it is not, then and there is no any question of compilation. It will generate an error for that particular line of code or for that particular token which is written wrongly and which is not identifiable by the compiler. And if it is not written wrongly, then it should go ahead with the rest of the process. That means it should go ahead with an arrangement that how to represent that source code using an intermediate representation IR, and then further it will go it will be hand over to the backend phases. Okay, so here the green blocks which you can see is some of the phases which are involved in analysis of the source code, and the second green block which is telling that here actually you are doing the synthesis. Synthesis means you are actually translating from your one type of language to other type of language. Okay, and between these two, one intermediator is there or intermediate representation you have to make so that these mappings of your front end to back end is smoothly possible. So sometimes what happens that in your front end or analysis, you conduct multiple passes, means you break down the whole process into multiple passes. From one pass, whatever output is coming out, that is been given into the second pass. From second pass, it is going to the third pass, and so on. So in that case, your compiler is compiling the or doing the analysis of the source code into multiple passes. So this is just done to understand the source code in a better way and to generate the output and to catch hold of the intermediate temporary outputs in a better way. Okay, so it happens sometimes, but sometimes it may not happen. At least single pass will be present there in your front end. Okay, so multiple front end means you are actually trying to conduct multiple passes. So in your front end, basically, I told you that you have to first understand about the source code. So is it your code is syntactically correct, semantically correct or not? So you are basically trying to recognize the whole lines, whatever lines you have written, you are trying to recognize each of these written tokens inside that particular code. If it is following the grammar rule set of that particular programming language, if it is following the semantics of that programming language, then it will not generate an error. Otherwise, it will generate a set of errors for that. Okay? And if it is successful to understand each and every constructs written in that particular programming language, then it will go ahead for producing the IR. That means it will try to generate an intermediate representation of your source. Okay, and along with that, whatever tokens it has recognized or whatever constructs or whatever small constituent pieces it has recognized, it will try to store them because why it requires the storing those tokens, because it has to segregate all the tokens according to its type. Means some of the token may belong to keyword, some of the token it will collect, they may belong to variable name, some of the tokens it has collected that may be according to your operator. Okay, so it has to identify that what type of token it has collected. Then only it can easily store them in a storage area which is called symbol table that I will teach you. In that symbol table, it will keep the record of every symbols it has collected in your source program. Okay. So this is a kind of synthesis, not synthesis, analysis you are doing on your source code. So that is why these phases which are involved in analysis, those belongs to the front end part of your compilation process. So like you can see here, suppose a simple line you have written like this that x equal to x plus y, suppose. Okay. So how this simple line will be broken down by your front end? That We have shown here. So here X is one identifier, equal to is an operator. Again, at the right hand side of the equal to X, X is an identifier. Then plus symbol is an operator. And then Y is again another identifier. So that means here basically compiler has got two different types of tokens here. One category is for identifier and or variable you can say, and another category is for your operators. So in your identifier, it has identified that there are two different tokens present here, X and Y, and there are two different operators present here, that is equal to and plus. So it will eliminate each of these tokens separately and will keep a record in your storage map or in your symbol disk. Okay, so this is the task of your first phase. In your front end, the first phase is lexical analysis. So the Lex tool is responsible for scanning the lines of code, and in each line, whatever symbol it is getting or whatever token it is collecting, its task is to keep a record of each token collected, and side by side what is the category of this token, that means the attribute of those tokens, that will also be stored in that particular storage map. Okay, now yes, anybody is saying anything, anyone is asking anything?
Minal, please mute yourself. Minal,
Is muted. Is if anyone is asking
Minal.
anything, you can ask. কেউ কিছু জিজ্ঞেস করছো? Okay. So in my front end, the next phase will come, the second phase of my compilation, which is known as syntax analysis. Let me go back to the phases so that you can see easily. First phase
Ma'am, can
is
you
your lexical
repeat the
analysis
first
phase.
part?
Sorry.
Madam,
Okay.
madam, can you repeat the first page?
First phase.
It was
First phase is the lexical analysis that I have just talked. Lexical analysis phase means it is just a scanner. Scanner means its task is to scan the source code line by line, and each line, whatever token it will collect, its task is to segregate each token from the other token by looking at the white space between them. Like you have written, suppose int I equal to 10. Suppose you have written. So in that particular line, compiler will find out int is a token because it's a keyword. Its category is keyword. Next, I is a identifier or variable name. It will identify I as a separate token and will keep its record as an identifier. Then equal to is an operator. It is also another token. It will keep its type as an operator. Then 10 is a constant or literal. It will store it in the symbol table accordingly. So it's a constant or literal. Okay. So in a single line, in a single C code, it has got four different types of tokens. So lexical analysis phase is basically responsible for collecting these tokens by scanning the lines in the present in the source code. Okay. In each line, whatever symbol it will get or whatever token it will store every token's record in the symbol table. But my point, come on.
yes, madam. Now it's clear.
So the first phase is lexical analysis. Next phase, which is also a part of your front end, that is known as syntax analysis. Okay. Now, syntax analysis is little bit clever than your lexical analysis. Why I'm telling clever? Because here actually the whole checking will be done. Just now I told that in front end, if some erroneous code is written, then straight away your compiler will not go ahead with the rest of the phases because it has identified some of the erroneous lines. So it will generate the error from then and there itself. So why I have told that? Because in front end only, you have understood the rules and regulations which are allowed according to that source language. So that means if I'm writing a C code and I'm following the grammar of or rules of my Java code, that is not possible, right? I have to follow the syntaxes. I have to write my code according to the syntaxes of the C language only. Otherwise, definitely my compiler will not know what I have written as a user, right? So that means someone needs there who will tell me that whether that line is according to the grammar rule or grammar set which is allowed in that particular language. Is my line written according to that grammar rule or not? Is my line is following those grammars, following those rules which is allowed in that particular language? If it is so, then it will follow it or it will pass it to the next phase. Otherwise, if my line is not according to the syntaxes, then and there it will throw an error. So that means in your second module, which is I'm talking about here as a parser. So parser is basically is checking those grammar portion. There comes the knowledge of your automata. I told you now the sum of the portion of your automata where up to the context free grammar you need that knowledge. So that means in that portion you require these grammar concepts. The context free grammar, context sensitive grammar, okay, Chomsky normal forms, whichever you have read in your previous subject theory of automata, up to that portion, at least you need knowledge because for each programming language, there are some grammar constructs, there are some production rules, there are some production sets which are already embedded when the compiler is created. At that time, these grammar rules are embedded within it. So whoever will use a particular programming language and will try to compile its code using that particular compiler. So his or her line should be aligned with that particular grammar rule set. Okay, so your parser basically recognizes the syntaxes and then it does that kind of analysis that whether your code is following that grammar rule set or not, whether it is allowed to write in that fashion or not, if you are using a particular source language. If it is not, then it will generate an error. That means correct this syntax, something is missing, okay, or prototype declaration missing, bracket is missing, and so on and so forth. Okay. Otherwise, it will, if it is correctly written, then it will go ahead with the next phase. Okay. So for that, again, another tool you will use that is known as YACC tool. This is a automated version of your parser code. So how does it do? How does this parser actually checks? So we will learn here that parser, what parser does, whenever some line you have written in your source code, it will try to form a kind of tree structure. Tree. Data structure you have read, no? In data structure you have read about tree data structure. So whatever line user has written, for that line it will try to create a tree-like structure. And if that tree-like structure is completed, then that means your line is following the grammar. And if that tree is incomplete, that means something is missing in that particular tree, some leaf node or something, that I will show you that how that tree structure will be generated. But as of now, just you remember that one tree structure output will be generated by this parser for each of the lines you have written. And if it is successful to create that tree-like structure, then it identifies that whatever line you have written in your source code, that is following the syntaxes, that is following the grammar of the particular programming language. Okay. Now, once that tree structure is created, that tree structure is known as a parse tree or syntax tree. That means at the end of your second phase, which is a parsing phase or syntax analysis phase, a parse tree will be generated. Now, if that parse tree generation is completed, that means whatever line it has judged, it is according to the grammar or it is according to the rule set. which is allowed in that particular source language. And if it is not successful to create that particular parse tree, so that in that case it will generate error. Am I clear up to this point? Anyone can respond up to this point? Whatever I have told, is it clear to all of you?
Yes, madam.
So like here you can see that when parser will get the tokens from the previous phase, that means lexical analysis phase. See here it has segregated each of the tokens separately. So suppose expr is an expression, okay, op is an operator, term is a uh, constant value or variable value, anything it can be. Okay, so likewise using these tokens, whatever lines user has written, it will try to form these kinds of rule sets. Okay, these rule set I will teach you. So these are basically the recognition of those tokens and representation of those tokens. So recognition is done by the lexical analyzer. Now when you have formed certain rules, that you will represent using RE, that means regular expression. There also you need some concept of your automata. Okay, in your automata you have read about regular expressions, no? So likewise you have to write the rules. So I will teach you that how to write the rules, but as of now you just remember that here your automata concept will require. Okay, whenever you will try to represent the tokens. So that means uh, what I have told you, that whenever any line is written by the user, at the end of your parsing phase or end of your second phase, which is syntax analysis phase, a tree-like structure will be generated. So see here the line, this is a single line. So what is a single line? Try to read the leaf nodes from left to right. Okay, so here the line is written x, then the rightmost leaf is plus, then its next rightmost leaf is 2, so nx plus 2, then minus y. So this is the expression basically. Okay, x plus 2, just read the leaf nodes from left to right. Okay, x plus 2 minus y, this is the line written by your user. Now parser has created such a parse tree or tree like structure as an output. At the end it has read the whole line. मतलब जब उसने ये line, let me tell you how it has been done. So slow system. So suppose what is the line here? X plus 2 minus y, right? So suppose this line is written by the user. So here remember, it will first aggregate each of the tokens separately. So this is an identifier, means variable. This is a terminal value or constant. So these are identified by your lexical analysis phase, means first phase. This is also another identifier. So it will try to categorize each of these. This and this is a operand. Okay. So why I am telling? Because in your symbol table, whenever it will store each of these tokens separately like this. That X is a token, first token. So its type is identifier. And what is its line number, size? Means if it is an integer, then it takes 2 bytes. If it is a float variable, then it takes 4 bytes and so on. So all these are attributes. So it will store in separate columns for that particular token. Okay. So likewise, the next identifier is that it has collected Y. It is also a type of identifier. Next is 2. 2 is a terminal value or a constant value or a literal value, anything you can say. Next is plus is an operator. Next minus is also an operator. Okay. Now once these separate tokens are collected by the lexical analyzer, the streams of token will be given to the parser, means its next phase or syntax analysis phase. Now parser will now see that whether this line is written according to the syntax of the programming language or not. Okay. So how would it check? It would check by creating that parse tree. So that means here, if I try to create only for up to this part, if I try to create my parse tree up to this part, how my parse tree will be generated? This plus is a binary operator, so it requires two its operand. One is at its left hand and another at its right hand. Otherwise, this addition operation cannot be done, right? So that means at its left hand, is it getting any operand? Yes, it is getting one identifier, which is X, and it is getting another terminal value or literal value at its right operand. So definitely, if I have this X value available, then I can easily perform this X plus 2. So that means up to this portion, my parse tree is okay and it is completed. Now I should move on to the right hand side. So in my right hand side, I have got another operator. So that means this is as a whole one expression. Maybe this is a temporary sub expression, but this sub expression is going to contribute to calculation of the whole expression, right? So this is a sub expression which is completed, because up to this sub expression my parts tree generation is complete. Okay. Now if I want to complete this whole expression, so that means I have to complete this parts tree. Now I will move for completion of this parts tree. So I will try to find out this sub expression minus y. Okay. Sub expression minus y. Now, as a whole, so this can be broken down like this. Thus, minus is a binary operator. It requires again two operand at its left hand and right hand. So, at its left hand, it is having this sub expression calculated completely. This is already done in the previous phase, or not in previous phase, in this phase only, but in the previous time cycle. Now, if I complete this subtraction operation, then this whole x plus 2 minus y will be completed, right? So now I can say that whatever line the user has written, it is according to the syntax of the programming language. Now you may ask me that, ma'am, is it written in the printf statement, or this whole expression is being assigned to some other variable? Yes, that can be done. If you have written like this, that z equal to this whole expression. So in that case, again, this whole expression can be attached with this left hand side variable z. So likewise, so in that case, again this parse tree is completed. So likewise, your parser basically checks that whether it is successful to create the parse tree from that written expression or not. or from those collected tokens and collected lines in that particular source code or not. If it is successful, then it thorough it and it says that yes, this line is according to the grammar of the programming language. Otherwise, it generates error. Suppose in this case, suppose this y is not present. Suppose अगर ये यहाँ नहीं होता, ओके, अगर ये यहाँ पे नहीं होता, y यहाँ पे नहीं होता, तो मेरा ट्री कैसे देखने में लगता कि this minus operator is having only one operand, though we know that this is not a unary minus, right? This is a binary minus. So binary minus में उसका right hand side जो operand है, this is missing. So अगर ये missing है, मतलब आपका सब ट्री जो आप create कर रहे हो from your sub tree, the whole tree you are trying to generate, that is incomplete. So if it is incomplete, that means something user has missed to write. Either that is missing or deliberately he has done wrong. So in both the cases, it is an error case. So if it is an error case, it will generate an error because it is not written according to the syntax of the programming language, source programming language. Getting my point? Hello? Are you all
Yes,
getting my
ma'am.
point?
Yes, madam.
What
Yes,
I am
madam.
trying to say?
Yes, ma'am.
Why
Yes,
this
ma'am.
tree creation is complete and how does it check?
Yes, madam.
Now, so that means we are in the analysis phase and we have completed two of its sub phases, we can say. One is lexical analysis phase, another is syntax analysis phase. Now in this analysis phase or in front end, we have another phase which is called as a semantic analysis phase or syntax directed translation. Let me go back to the phases so that you can understand. The third phase, this one, this is syntax related translation phase, or you can say it as a semantic analysis phase. Okay, there what happens if your parse tree generation is complete, which I have just shown. Suppose आपने यहाँ पे parse tree generate कर दिया है और suppose यहाँ पे आपको कुछ type casting pending रह गया, you have to perform some kind of typecasting, some kind of type promotion you have to conduct for certain variables, certain identifiers, okay, for certain constant value from one constant to another type of constant you have to convert. So in that case, these incomplete annotations which are not done at the syntax analysis phase, that is basically resolved at your semantic analysis phase. Okay, so that is why the semantic analysis phase is also a part of your analysis and it belongs to your front end. Okay, now जैसे आपका ये फ्रंट एंड के तीन फेजेस जो मैंने ऊपर से नीचे फर्स्ट, सेकेंड और थर्ड, ये तीन फेजेस मैंने जैसे ही कंप्लीट कर लिए, my front end is done. That means whatever analysis I need to be done for my source language, that is over. Now I should represent my source code into some form which is called as a intermediate code generation, IR form. Okay. So IR form कैसे लिखते हैं, that we will discuss separately in those chapters. But as of now आप just जान के रखो कि source code से direct हम लोग कभी भी टारगेट कोड में ट्रांसलेट नहीं करते हैं, मैपिंग नहीं करते हैं. We first represent it in a IR version, that is intermediate representation we do, and then from that intermediate representation we go ahead with the backend phases. So that means the rest of the three phases which you are looking here is runtime environment, code generation and code optimization. These three phases belongs to your backend phase. So what happens in case of your backend phase? Let's see. So in case of your backend, basically you are trying to convert. So whatever you have represented using IR, that you are now want to map to your target code or machine level code. Okay, so in that case you do this kind of translation. So this is known as a synthesis. So after synthesis, these whatever constituent parts you have collected from your IR, you now create a object code which is a output of your compiler. Okay, so that is why these three phases, where this runtime environment, environment checking or code generation or code optimization. So these three are basically involved with the synthesis of the IR or intermediate representation. So that is why they belong to your backend phase. Okay. Now let me go to those portion. This I have told. So this is basically your abstract syntax tree, which is the output of your semantic analysis phase. Where I told you, key type casting, type promotion, any kind of type conversion, if you are pending with, so those are resolved in your semantic analysis phase, which is a part of your front end. Okay. So that means your front end portion is over. Now you are represented your code using intermediate representation or IR. Now you are planning to map it to machine code. So that means the translation will now take place. So this backend is responsible for doing this. So what it does, it translates your each line of your IR into target machine code, and for translating this IR to target machine code, whatever machine instruction, whatever operation you have to do. So that means right from allocation of your registers, right from loading those data from memory and back to storing those data to the memory. So all these loading, storing operation, or all these register calculation operations, these are basically tasks of your backend, which actually requires the help of your computer system or computer hardware. Okay, so how many register you need for particular line execution, whatever you have written in each line, how many register you need, because you will take the input into those registers. So sometimes it may happen that there are three instructions code you are following, or you are using two instruction code, or even one instruction and zero instruction. In zero instruction, you only use push and pop operation using stack. Okay, so depending on the type of line you have written, you have to choose those instruction, and for those instruction, whatever of code, whatever machine cycle you need to perform, that are decided by your backends. Okay, so at each time, how many registers are in track, or how many registers are involved, which are free to use for the next instruction. So those performance checking is done at your backend. Okay, so what are instructions you are selecting, what are register you are allocating, and how you are managing for performing a translation process for each line, that is decided at the backend. So that means whenever your instruction is selected, you know whatever instruction is suitable for that particular line, using that instruction code, you will allocate that many register. You will manage your addressing modes accordingly, whatever addressing modes will be suitable for performing the faster result. So that you will conduct for generation of your machine level code. So basically here we are not right now interested whatever was written in the high level language. Basically we are now come to the end of the compilation process. So we are in the process of generating our object code, which is basically close to machine level code, right? So for that you have to address whatever resources you are having, and whatever instruction user has written using IR, whether these resources are enough to deal with that particular IR. If it is not, then it has to separate its constituent parts, because you are not having those many registers, suppose. Okay, so these managements are done at the backend. So in that case, you have a value in a register and when to use it. If you have limited resources, like I said, you have not that many registers, then how to use those resources, how to allocate those resources in an optimal way to deal with some difficult lines of code, difficult situations. So these are part of your backend management. Okay, so that is why we can do these improvements in this fashion also, that we will keep this whole process of compilation process into three parts. One is front end part, another is back end part, which we have already read. In between these two, we can introduce one more phase or one more segment, which is known as a middleman or middle end. Okay, so this middle end will do the difficult task on behalf of this front end. So that means this middleman will keep your code in a ready-made fashion. That means it will try to optimize your IR. Whatever IR or intermediate representation your front end has generated, if there is any scope for improvement after this generation of IR, then middleman or middle end will do that change to reduce the overall running time, overall execution time, or overall your object code generation time. Okay, so as much as simpler code you can write in your IR, that much simpler will be your translation, because it will be easier for backend to allocate the register. It will be easier for backend to utilize your limited resources. It will be easier to store those variables back to memory in a proper place. Will be easier to access from memory when it is needed, and so on. Okay, so effective goal is to divide this whole process into three parts, is to reduce the overall running time. So this overall optimization is basically what it is doing. It is using some of the optimization techniques. These optimization techniques, which you can see here, that we will discuss whenever we will read that chapter, which is code optimization techniques. Okay, so constant propagation, if any sub expression to be eliminated, which is common, if there is any redundant information which is stored, so that should be eliminated. If there is any dead code which is in an unreachable state, that should be eliminated, so and so forth. So these sometimes are present in your code, which needs to be removed before translation. So your code optimizer or your middleman or middle end actually does this on behalf of your front end, so that your backend can smoothly translate it to object code, and the overall effective execution time can be reduced. Is it clear up to this point? If any one of you have a problem up to this point, you can ask me. Anyone is having any problem? Anyone is having any question even? Is it clear? Is my voice audible?
Yes, madam, your voice is audible.
No one is saying
Ma'am, we have
yes
to.
or Sontu Ghosh?
Yes, ma'am.
বুঝতে পারছো?
হ্যাঁ ম্যাম।
বুঝতে পারছো যেটা পড়ালাম আজকে?
হ্যাঁ ম্যাম, বুঝতে পারছি।
আচ্ছা, ঠিক আছে। Satyam, is it clear? Satyam, am I audible to you? Satyam?
ম্যাম চ্যাটে ও ইয়েস লিখেছে।
আচ্ছা আচ্ছা, ওকে ওকে okay. So up to this point I have cleared that how actually your front end and your back end works. Now yes, this portion I have to show you that the 7 phases which I have just segregated into front end and segregated into back end. So basically these processes looks like this. That means from the top, if I discuss, that you give input this lexical analyzer phase, this source program. So what this lexical analyzer phase does, it first tries to scan each line written in that source code. Now whatever it has collected as an output, that means the string of tokens, it passes on to the syntax analyzer. The syntax analyzer tries to analyze whatever tokens is collected and tries to find out the tree structure construct out of those tokens for each line. Now, if it is successful to create that parse tree at the end, then it again thorough it. If there is any pending cases of your type promotion or type casting in your parse tree, then that annotations and type conversions are resolved by creating abstract syntax tree, which is the output of your semantic analyzer, which is the third phase. Okay. Now, what I wanted to show you that in each of these phases, you can see the arrows are going in these two common blocks. One is at the left hand side, this symbol table manager, and at the right hand side, error handler. So these modules are actually not phases of your compilation, but these two are essential part of your compilation process, because every module for its work, they need to reference these two different modules. So whatever lexical analyzer has kept the record for each of the tokens, that is needed by IR, that is needed by your code optimizer, that is needed by your syntax analyzer, that is even needed by your code generator phase. Similar way, whatever error will be generated, so every record will be kept or will be handled by your error handler. So that is why the arrow is connected to every phases from the error handler in each of these phases. Okay, so this is the overall diagram. Now tomorrow we will start discussing from our lexical analysis phase. Okay, from lexical analysis phase we will see that how does it recognizes tokens, what are tokens, then how can we form lexemes, okay, how can we form patterns, how can we recognize our tokens, how can we represent our tokens using grammar, and so on and so forth. Okay, so up to this portion, if you have any doubt, then you can ask me right now. If anyone is having any question up to this portion. Yes, Neha, any question?
No, ma'am.
No? Okay, then I am winding up my class here today. Let me take your attendance.